All right. And of course it freezes. Love that. Guys, stop. As this is going to be an issue, you will have a seating chart by tomorrow. So, like I said, quit the crap. All right. So, we have a rectangle here. Before we do anything, we're just going to calculate the area of that rectangle. So, who remembers how to calculate the area of a rectangle? Length times width. Now, how can I determine my length and width of this rectangle? Just count the units. So what's my length? 3 is my length, 2 is my width. So, y'all, it doesn't really matter. So we would do 3 times 2, which is what? So this would equal 6 units, what? Squared. Now, the next thing that we're going to do is draw this same solid again. So we're going to redraw our rectangle using the same points. But now we're going to draw the solid rotating around it. So first off, if we rotate around it, we already did this. If you're given a rectangle and you rotate around the x-axis, what are you going to get? A cylinder. So it should look something like this. So you got circle goes that. Let me connect the lines here and here. So there's your cylinder. So I rotate that rectangle over the x-axis and it creates that cylinder. Now, we need to calculate the volume of the cylinder. So I gave you this formula yesterday. It's also on that blue sheet. What is the formula for volume of a cylinder? Nope. Guys, it's on that reference sheet. If you have it out, it's right there. So it's on that blue reference sheet I gave you with all the formulas. What's the volume of a cylinder? Pi r squared h. So pi is just a constant value that we all know to be 3.14, whatever. All right. So we need the radius and the height. All right. What do you think the radius is? It's what? It's 2. So if you look, our center of the circles are right here. And the width of the rectangle is actually our radius of the circle. Because it goes from the center of it to the edge. So our radius is 2. What do you think the height is? 3. So your height is from center to center. So right here. Or you could also do it on the side. So it would be the length of the rectangle, which is 3. So I'm going to just put it right into my formula. This is pi times 2 squared times 3. Now, we're going to simplify this down so it's just a number times pi. That's going to be our exact version. And then we're going to put it in our calculator to get the approximate version. All right? So, what's 2 squared? So I get pi times 4 times 3. What's 4 times 3? 12. So our volume is equal to 12 pi units cubed. That's our exact measurement, which would be approximately, so in my calculator, and you want to use the pi key because we want the exact amount. So in your calculator, you're going to type in 12 times, hit the second key, and then hit the little caret key. So whatever you would do to raise to a power, which is above the division sign. So hit this key right here, and that'll input pi. All right, so don't put 3.14, do the actual pi. So again, second, and then the key above the division key. And then hit enter. So let's say I rounded to the nearest hundredth. What would that be? 100. Right, 37.70 or just 37.7. So this is about 37.7 units cubed. So again, this is our exact. This is our approximate. Why am I showing you both? Because on your test you may see both. May ask you either keep it in terms of pi or give you the approximate. Now, that was when we rotated about the x-axis. All right. Now, let's rotate around the y-axis. So if we rotate that same rectangle, so I'm going to draw it again, around the y-axis, what would it form? Still a cylinder. So I'm going to make it as best as I can. So I'm going to start here. I'm going to rotate all the way around and do the same thing over here. And then connect them. It's not my best cylinder, but it's good enough. All right. So just draw it the best you can, guys. So it's not going to be perfect. So if we calculate the volume, all right, still using the same formula. So volume is equal to pi r squared h. All right. What's my radius? 3. So the radius centered to the edge of the circle, it's actually the length of this rectangle now. So this is 3. What's the height? 2. So the height would be the width of the rectangle, which is 2. So radius is 3, height is 2. I'm just going to plug it into the formula for its respective spots. So volume is equal to pi times 3 squared times 2. What's 3 squared? 9. So I have pi times 9 times 2. 9 times 2 is 18. So volume is exactly 18 pi units cubed. Put that in your calculator. Give me an approximate. It's around to 2 decimal places. Wow. 56.55 units cubed. Now, why do you think the volumes are different? So we're essentially using the same numbers. We just switched which one was the radius and which one was the height for both of them. So between rotating around the x-axis and the y-axis, why are those two volumes different? What part of the formula really messes with the volume of the cylinder? So if you look at both of these, between D and F, look at how we set them up. What's kind of the big thing that really changes what the numbers are? Well, the radius and the height flipped, But there's one part of the formula, because isn't multiplication commutative, meaning whatever we multiply, we'll get the same number, right? But why do we not end up getting the same number, even though we're using the same two numbers? There's one piece of this formula that's screwing it up. Not pi. Pi is just a constant. It's the same for both. I heard it. What is it? It's that square. So this r squared is what's messing with us. All right, because once you throw in a square, multiplication being commutative no longer applies, because there's a difference between 2 squared and 3 squared. All right, so the volumes are different because we get different values for r squared. So in other words, 3 squared is not equal to 2 squared. Another way you can put it is that the radius and height flip. So if I gave you a problem like this, you got to be careful and identify which way you're rotating first off. So if you're rotating a rectangle around the x-axis, it should look like a cylinder on its side. If you're rotating all over the y-axis, it should look like a cylinder that's just standing straight up. All right. And then you should have to determine the radius and the height based off of that. And they should end up flipping based off whatever the dimensions of the rectangle are. Any questions on that one? All right, let's look at a different one. So, first things first, take a minute, plot those 3 points. So I got 0, 0, 0, 3, and 2, 0. So once you plot those points, you should get a triangle. Now, it then asks us to calculate the area of the triangle. What is the formula for area of a triangle? It's on your sheet. So base times height divided by 2. So base times height divided by 2. So what would my base be? 2. So your base is equal to 2. What's your height? 3. All right. So I'm going to do 2 times 3 over 2. So that's equal to 6 over 2, which is what? 3 units squared. So that's the area of my triangle. So the area of that triangle is 3 units. Now, we're going to regraph this triangle on the next graph. So graph those same points again. Now, recall when we did the activity online. If we're given a triangle, if we rotate around the x-axis, what shape will it form? A cone. All right, so we're going to get a cone when we rotate it around. So I'm going to do this as best as I can. So it will look something like this. All right, so there's your cone. All right, now it then wants us to calculate the volume of that cone. So if I were to calculate the volume of this cone, so look on your reference sheet. First off, what is the formula for the volume of the cone? 1/3 pi r squared height. So it's pretty much the same thing as a cylinder. You just multiply 1/3 to it or divide it by 3, however you want to put it. All right. So we definitely need the radius and we need the height. What's the radius of this cone? It's 3. The circle's right here. So the radius is 3. Shh. What's the height of the cone? So from center of the circle to the tip. 2. It's from here to here. So that's 2. So guys, here's a hint. Whatever the base and height are of the original triangle, that's the radius and height. You just got to look at where they are in the cone. Say that again. All right, so now I'm going to plug this in and calculate. So 1/3 pi times 3 squared h, not h, 2. All right, so let's get it in terms of pi first. So what's 3 squared? 9. So I have 1/3 pi times 9 times 2. What's 9 times 2? So I have 1/3 pi times 18. Now, what's 1/3 times 18? So that's the same thing as doing 18 divided by what? 3. So if we do 18 divided by 3, what is it? So this is exactly 6 pi units cubed. What is that approximately? So put in your calculator around to 2 decimal places. 18.85 units cubed. So that would be the volume of that cone. Now, stop. Now, we're going to redraw the triangle again. So same points. But now we're going to rotate it around the y-axis. So if I rotate this around the y-axis, what shape do you think I'm going to get? Still a cone. All right, so if I were to draw it, it looks something like this. All right, there's your cone. It ain't the prettiest cone, but whatever. Actually. That's better. Okay. All right, so there's my cone. I'm going to still calculate the volume of this cone. So the volume, it's still 1/3 pi r squared h. So I need my radius and my height first. What's my radius? 2. If I go from the center to the edge, that's 2. What's my height? 3. Center to the top, 3. Put it back into my formula. I have volume is equal to 1/3 pi times 2 squared times 3. What's 2 squared? 4. So I have 1/3 pi times 4 times 3. What's 4 times 3? 12. So I have 1/3 pi times 12. 12 times 1/3. It's the same thing as 12 divided by 3. 4. So this would be 4 pi units cubed. So it's approximately what if you put in your calculator? 12.56 or 57? 57. So just like last time with the cylinder, even though we're using the same numbers, we got different volumes. Why? Because of that square again. All right. So because of the r squared, or what we plug in for r squared, we get different volumes, even though we're using essentially the same numbers. So guys, on your test, if this was on your test, you'll typically be asked, given either a rectangle or a triangle, and asked to rotate either around the x or the y axis. All right. And then all you have to do is determine whether it's going to be a cone or a cylinder, and then figure out the measurements. All right, which it's usually the dimensions of the triangle dash rectangle. Now, let's do one that's a little bit harder. Where is it? Ah, okay. All right. So look on page 16. So we're going to do the problem together on page 16 because this one's a little bit different. And I'll show you why. All right. Shh, shh, shh. First off, take a minute, plot those 4 points. So it's 0, 0, 0, 3, 5, 0, and 5, 3. So we got ourselves a rectangle. So page 16, it should be problem number 4. You'll see why I'm doing this one once we get down to the last problem. All right, so first off, I want to calculate the area of this rectangle. So we know that area of a rectangle is what? What's the formula for area of a rectangle? Length times width. So if we count the units around my rectangle, what's the length? 5. What's the width? 3. So we do 5 times 3. Area is 15 units squared. Now, we're going to redraw this figure, but then rotate it around the x-axis. So I'm going to redraw the figure. I'm going to rotate it around the x-axis. So it's going to look something like this. And we know it creates a what? It creates that cylinder. Now, this is kind of just more of the same. All right, we've already done this already. So now if we calculate the volume, what's the formula for volume of a cylinder? Pi r squared h. If you notice, guys, it's basically the area of the circle times height. So pi r squared times height. All right. So I need the radius and I need the height. What's the radius of this cylinder? 3. It's from here to here. That's 3. What's the height? 5. Here to here. It's 5. Plug it in and find it. So this would be B is equal to pi times 3 squared times 5. What's 3 squared? 9. So this would be pi times 9 times 5. What's 9 times 5? 45. So 45 pi units cubed is my volume. What is that approximately? You put in your calculator. So you 45 times pi in your calculator. What do you get? 141.37 is what you said? Okay. 37 units cubed. All right. Now, that was pretty much more of the same. But let's look at this last question. There's a key difference. So, we're still doing the same. All right. So, we're still doing the same shape. So, we're just going to take a minute, draw it real quick. Now, here's the question. What's different about this problem compared to others that we've done? It's not revolving around an axis. It's revolving just around a vertical line. That vertical line is x equals 5. Now, because this will essentially result in the same cylinder, I want to actually change this a little bit. So instead of it equaling x is equal to 5, I want it to equal x is equal to 6. And you'll see why I want that in just a second. So, if I want x is equal to 6, I'm rotating around this line right here. So, what's going to happen is that you're going to create a cylinder inside of a cylinder. All right? So, in other words, it's going to look like a cylinder with a hole in it. So, the baby cylinder is going to be right here. So, this is the baby cylinder. The big cylinder is going to be all the way out here. So it's literally a cylinder with a hole in it. Now it looks funky because I can't draw for crap apparently, but essentially what it's going to look like if I just drew it outside of it, it's going to look like this. You guys see it a little bit better now? It's going to look like a toilet paper roll, guys. All right. So in other words, the big cylinder is the toilet paper. The little cylinder is like the little roll thing. All right. Now, we want to calculate the volume of the solid. So let's think about this logically. All right. So, how do you think I would calculate the volume of this solid? Okay.
Take the volume of the big cylinder and the volume of the small cylinder and subtract small cylinder.
Right. So, you would take the volume of the big cylinder and the volume of the small cylinder and then subtract them. All right. So, first off, be careful about this. So if you ignored the middle cylinder, what would be the radius of the big cylinder? 6. So since we're going all the way to the middle, that's right here. So you just add one. Whoa, I don't know how that happened. So you just add one more. All right. So the radius of the big cylinder would be 6. What's the height? The height's still whatever the width of the rectangle is. It would be 3. Put it into the formula. So it would be pi r squared h. So that's equal to pi times 6 squared times 3. So what's 6 squared? 36 times 3. And then what's 36 times 3? 36 times 3, guys. Got a calculator. Use it. 108 pi. So 108 pi is the volume of my big cylinder. Now, I want the volume of the small cylinder. So, what is the radius of the small cylinder? So think if the center's here, how far is it to the edge? 1 unit. So the radius is 1, and the height will still be exactly the same. So the height's equal to 3. All right. Now, so if radius is 1, height's 3, I'm going to put it in my formula. So pi r squared h is equal to pi times 1 squared times 3. Guys, hush. So this would be pi times 1 times 3. So that'll just be the volume of the small would just be 3 pi. So using these two volumes to get my total volume. So to get my total volume, all right, I'm going to subtract those two volumes. So I'm going to do 108 pi minus 3 pi. Now, this is kind of like combining like terms. So since they both have pi in them, you can just subtract the coefficients. So this would be 105 pi units cubed. But what is it approximately? So do 108 pi minus 3 pi in your calculator. Tell me what it is approximately.
That's 86. Wait, 87.
Okay. Now, just to check, do 105 pi in your calculator and see if it's the same. Good. So this would be your total volume of this toilet paper roll. Now, why I'm telling you this, you will see the occasional problem like this, especially on your test. And we'll talk more about this tomorrow. All right. But I'm just kind of giving you a prelude now. But this is essentially how you would handle it. All right. Any questions on this? All right. So your homework for tonight, all right, is, or at least your assignment for right now, you have another quizzes and a Delta Math. All right. So pick one and work on it for the next 25 minutes. And everyone needs to be working on something. So if you did that intro from yesterday, which is a grade, that Delta Math from yesterday If you did it like I told you to, calculating volume shouldn't be too bad. Yeah, go ahead. Yeah, just make sure you sign on to the class.